Welcome to week 4. Last week we set up the test project, learned the AAA pattern, and ran our first test for the Mega Travel project. This week we're going to go deeper. We're going to understand how mock works, the setup, returns, and verify methods, and by the end of lab today, or at least this week, you will have written your first unit test yourself, right? A real milestone. So the test you write today is the same pattern that you'll use for basically every controller test for the rest of the semester. So let's make sure you understand it well enough to repeat it on your own. Just a little bit of recap. What did we do last week? What are we doing now? So before we move forward, we should have our Mega Travel API tests project in your solution set up with MS Test and mock installed. So you have your project reference to the API and one passing test. So we set up the get all users with valid users return success response. And if any of those are not true, get that sorted out first before moving on. Today, we'll add a login user test, which introduces some new mock syntax, and then you'll write the empty list edge case test yourself. So 3 tests total by the end of this module. So let's start with, what is mock? Because I keep talking about it, and you're like, I've never heard of this before. And I get it. You probably have never heard of mock before. So the user DAL needs a SQL Server connection to work, right? Hopefully at this point, we've looked at the code, we understand how data comes through our object relational model, that's Entity Framework, from SQL and gets put into memory as populated data classes. If we used the real user DAL in our tests, every test would require a running database with the right data. If the database is down, all of your tests fail, even if the code is perfect. And when we think about testing, that's not a test problem. That's an infrastructure problem. And we really don't want to mix the two ideas. Mock solves this by creating a fake object that implements iUser. The controller sees something that fulfills the iUser contract, and it has no idea it's not the real DAL. So this stunt double analogy I really like. It's one that kind of clicks for people. The director, that's your test, tells the stunt double, that's the mock, exactly what to do. Jump here, fall here, return this value. The actor, that's the controller, just interacts with it normally without knowing that it's fake. The audience gets the same end result. And critically, this only works because user controller depends on iUser, not directly on user DAL. If the controller created its own user DAL internally, we'd have no way to inject a mock. And so as we talk about architecture, which we talked briefly about in week 2, this is the payoff from making sure that your application is set up correctly. So let's talk about what exactly setup and returns does. The top example shows a synchronous method. Get all users returns a list, not a task. So we use .returns, and we read it like this. When someone calls get all users on this mock, return mock users. That lambda r is saying r is the mock, and when r.getAllUsers gets called, that's what setup is configuring. Then returns says what to hand back. Now look at the bottom example. Login users is async. It returns a task login response. For async methods, we use returns async instead of returns. Same idea, just a little different syntax because of that async wrapper. And notice it is any login model. So that's saying I don't care what login model gets passed, return this response for any login model. So let's look a little more closely on the next slide. It's important to understand this because it's a decision you'll make every time you write a mock setup. It is any of a type, right? And we say that using the bracket T when you see that in documentation, has to match any value of that type. So if you use it is any login model, the mock will return your configured response regardless of what username and password was passed in. This is the right choice most of the time. You're testing how the controller handles the response, not which specific credentials were used. The specific value approach is for when you want to test a particular scenario. Maybe you want to prove that when Susan S. logs in, she gets a specific response. Less common, but more precise. My advice is to default to this pattern, it is any, and use specific values only when the test is asking specifically about a particular input value. So then verify. And this is probably the most powerful tool we haven't looked at yet. Assert checks what came back. Verify checks whether a method was called at all. So take a look at the syntax. It looks just like setup, but it's checking after the fact rather than configuring before. Times.once is what you'll use almost every time. The method should have been called exactly once. Times.never is actually very useful. It lets you prove that something correctly didn't happen. I know that's a little tricky, not logic. And times.exactly is handy if you have a loop. So the key insight is in the call out here at the bottom. Verify lets you prove the controller actually called the DAL and not just that it returned the right value. Those are two different things. The controller could theoretically return a hard-coded success response without ever calling the repository. Assert would not catch that. Verify would. So if you're asking yourself right now, well, when would I use verify? Here are some scenarios to help this make it a little more concrete. First, after login, you assert that the response has a status of true and it has the right user data, but verify confirms the controller actually called login user on the repository. Without verify, a clever but broken controller could return a hard-coded success without ever checking credentials. Second, after an update, did the controller call update user record exactly once? This catches bugs where it gets called twice by accident or skipped entirely due to a logic error. Third, when input is invalid. This is times.never. If someone sends bad data to the registration endpoint, you want to prove the controller rejected it without touching the database at all. Assert can't prove absence. It can only check what came back. Verify can prove the negative. And you'll see all three of these patterns across the tests that you write this semester. So before you open the test file, I want to walk you through what's new so nothing surprises you. There are 4 things. The first thing, the test method signature is async task instead of void. Login user is an async method, so the test needs to be async as well. You'll use await instead of .result. Second, there are 2 setup calls instead of 1. The login user controller calls both login user and find by name on the repository. If you only set up login user, The test will fail when the controller tries to call find by name and gets a null back. Always check what methods the controller calls and make sure they're set up. Third, returns async instead of returns. So you've seen the theory, now we get to do it in practice. Fourth, verify appears at the end after the assert section. This confirms login user was called exactly once on the repository, and you want to read through the test carefully before you run it. Understanding what it's doing is part of the assignment this week. So then it's your turn. The scaffold gives you the structure. Your job is to fill in the to-dos. And before you write a single line of code, answer these 3 questions. What should the mock return? And in this case, we're looking for an empty list, a new list of type user with nothing in it, that simulates calling getAllUsers when there are no users in the database. What will the controller do with that? Do you know? So if we open getAllUsers in the user controller and look at what happens when users.count equals 0, you'll see it sets the status to false and the status code to 404. That's what we're testing. So what do we assert? Result, not null, status is false, status code is 404, and userList.count is 0. The hint at the bottom is maybe the most important thing on this slide. The pattern is identical to last week's test. You're not really learning anything new, but you're applying the same pattern with different values. We use the same mock setup, the same AAA structure, a different return value, and different assertions. So if you get stuck, go back to last week's test and compare line by line, and of course reach out if you have questions. So for this week, we're doing several things, and we are going to accomplish some of these in our lab. Items 1 through 3 are the pre-written login user test. So we want to download, add, run, confirm green. Do not skip step 3, running all tests together before moving on, making sure we didn't break anything. If the getAllUsers test from last week is suddenly failing, something broke and you need to fix it before writing new tests. Items 4 through 6 are yours. You're creating the new test class, writing the test, getting all of your greens. Your commit message for your feature test number 1, I've got that in there for you. Please try to keep your commit messages to what I ask so that it makes it easier for me to find and grade your submissions. And when all of your tests pass and you know you have your commit up on Azure DevOps, then that's the signal that you're done. And after today, you have a real test suite. 3 tests that automatically verify behavior every time you push, and that's the foundation of everything else you'll be building on. See you in lab.